Okay. Hello, everyone. Stream should be up and running now. Yeah, so welcome back. This is day 3 of day 4 of Advent of Code. Day 3 was, of course, yesterday. Um, Again, I haven't looked at this. Today I haven't even seen anyone talk about it. So I have no idea if this is going to be a hard one or an easy one, or yeah, I don't know anything about this one. So let's jump into day 4. Day 4, giant squid. You're already almost 1.5 kilometers, almost a mile, below the surface of the ocean, already so deep that you can't see any sunlight. What you can see, however, is a giant squid that has attached itself to the outside of your submarine. Well, that's not great. Maybe it wants to play bingo. Then there's a link to Bingo American version, which just seems to be normal bingo. Bingo is played on a set of boards, each consisting of a 5x5 grid of numbers. Numbers are chosen at random, and the chosen number is marked. Marked on all boards on which it appears. Numbers may not appear on all... Wait, what? Numbers may not appear on all boards. Numbers are chosen at random, and the chosen number is marked on all boards on which it appears. Numbers may not... Oh, right, so not all the numbers may not appear on all boards, right. If all numbers in any row or any column of a board are marked, that board wins. Diagonals don't count. Okay, so that's makes it a bit easier. The submarine has a bingo subsystem to help passengers. Currently, you and the giant squid pass the time. Well, that's handy. It automatically generates a random order in which to draw numbers on a random set of boards. Your puzzle input, for example. So it takes a bunch of numbers and a bunch of squares, or a bunch of like boards. All right, so these are the numbers that are drawn in that order, and these are my boards. After the first 5 numbers are drawn, 7, 4, 9, 5, and 11, there are no winners, but the boards are marked as follows. Right? That makes sense. After the next 6 numbers are drawn, there are still no winners. Finally, 24 is drawn. So this one would not complete one there. Would not complete one there. Yeah. So this line would complete. At this point, the third board wins because it has at least one complete row or column of marked numbers. In this case, the entire top row is marked, blah, blah. Yep. The score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on that board. So the sum of all these that haven't been drawn yet. In this case, the sum is 188. Then multiply that sum by the number that was just called when the board won, 24, to get the total score. To guarantee a victory against the giant squid, figure out which board will win first. What will your final score be if you choose that board? Right. So let's get the puzzle input. Again, of course, a much larger input set than the test sets. So there is one line with numbers, and then a new line, and then the boards in their 5x5 configurations. So how do we want to do this? We could, of course, play each board and calculate So we'd go through each board, run it through the numbers, then calculate how fast it wins, and then the score, and then at the end of the whole thing, figure out which one was the first one. Or we could read in all the boards and simulate going through these at the same time, which would probably be faster. I mean, we have to do them all up to a certain point anyways. But then we need to keep them. So how do we want to model this? I guess we could do them as two-dimensional arrays. Are these the same size? So input for day 4. Yeah, so these are also 5 by 5s. But let's start with reading in our numbers. So let numbers be well, let's use the streams module here. New file stream from input.txt. That is my input, and then my numbers is input.readline dot split on comma dot map parseInt. So that gives me actual numbers and not strings. Let's see. We need secutils for map. There we go. So this should now give me all the numbers. That looks good. We can of course also close the stream at the end. So that's all our numbers, and then we need our boards, which is a sequence of arrays of length 5, of arrays of length 5. So this is a 5 by 5 array of integers, and we have a sequence of those. So we need to skip a line. I guess we could do while input. So while the input is not at its end, we need to discard. So we have read the first line here. Now we need to discard the second line. So discard input.readline, and then this will be our new array entry, or our new sequence entry. So we should do let's create a type. Type for board is an array 5 of integers, and this is a sequence of boards. So that's just an alias for that. And then we need read in the new board as a board. So this variable is now a 5 by 5 array. And then at the end here, of course, we want to add this new board to our sequence of boards. But before we get that far, we need to do this. So loop 5 times, then new board I is equal to input dot read line dot split, and we need to split this on a space because these are space delimited. Ooh, but they can also have multiple spaces. I'm not entirely sure this behavior of split. Let's see. Split with a character. Yeah. So two spaces after each other will create two entries, which is not what we want. I guess maybe split white space. Yeah. Split white space should work. Split white space. But that is now a sequence, and obviously not of integers. Now it's a sequence of integers, and we need to convert this into an array. How would we do that? Because sequences in them are static. No, sequences are dynamic. Arrays are static. So this array is compile time defined to be 5 elements long. But obviously, when we read in from a file and do a split and stuff like that, we don't know, like we can't compile time know the length of this thing. So I'm not sure if there is an easy way to convert that into a 5 long array. The easiest solution would obviously be to do this, but that is a bit hacky. I don't think, like, we can't cast it. Maybe we could convert it to an array. But I don't think so. No. So let's write a procedure real quick that does that. Let's create a board line, which is an array of 5 integers. And then our board consists of 5 board lines. And then we have a procedure to board line, which takes in a sequence and returns a board line. And this does for I in 0.4. Result I is equal to xi. We can throw in an assert here for good measure. I mean, we know that this is going to be the case for us, but just a general case thing. And this is interesting. So this will work. This will now read in all the boards. Yes, that should read in all the boards. And this will discard. So this discard will first discard this line, then it will do this thing, then it will discard this line. So that should actually be all that we need to read in the whole file. Good. So if we now do echo board, echo boards, it should show us kind of illegible, but this is a sequence of arrays, and this looks, that is one board. So that looks correct. What we can do, however, in nim, is we can write this as a converter. And that means that this is automatic. So when it sees that I try to assign a sequence of integers to something that is an array of 5 integers or a board line, then it will go looking like, oh, I don't know how to do this. And then it will go looking for a 2 board line or a converter that takes this as an argument and returns this. So now that is implicitly being called for us, and we get the same thing. We also call echo on boards, which, as you saw, is not all that readable. So what we could do is we can define, and this is actually a procedure, because echo takes a string or something that has a dollar procedure and can be turned into a string by this procedure. And it's just like you can define procedures like this yourself. It's not, echo isn't any special. So the dollar here should take in a board and return a string. And that means that we want to build this string. So we're going to do for I in x.length, which is always going to be actually x.high, which is obviously always going to be 5, but if we change this definition, then this is going to be updated. And then for column in 0 dot 0 dot line dot high result, add this to the result, and that should be column turned into a string, but we want to align this with the align procedure from stereotils, which takes, let me see, takes a string, a count, and a padding character, which is a space, which is what we want. And we want this to be, let's say we want this to be 3 characters long. And for each of the lines, we want to add a new line. Should be high values, high type. What? Oh, that seems to have gone into an infinite loop. Copy mem time. What do you mean by that, Solitude? Let's see. Where did this? Line 19. So apparently here. I don't think it like that. Let's try this real quick. Yeah, so that works. Although it did spit out the... Oh, right. Right. So for line, this could just be line in X, and this should just be for column and line. There we go. So yeah, this just loops over all the values and not all the indexes, because we don't really need the indexes for anything. So just loop over all the board lines, and then all the board lines can generate this. We could also do something where we write a dollar for a board line, and then we write a separate for board that calls board line. But so yeah, that looks okay-ish. I mean, we could write one if you wanted to for a sequence of boards, which we'll just do for board in X, result and equals dollar board and a new line, for example, and that will give us something like this, which is a bit nicer. So yeah, it's converting a sequence to an array. Yeah, we could have done that with copy mem, for sure. I mean, this is literally just copying every entry from the sequence to the array, which is a super bad way of doing it. But I'm just trying to show off NIM features here, more than writing fast, solid code. What we could have done was use this copy mem, this thing. So grab 2 pointers and a size, which, I mean, it's not the prettiest, but we could have done destination first. So results 0.adder, x 0.adder, and then 5 times size, or actually we could have just said size of a board line. So we could do that instead. All right. NIM differentiates between address and unsafe address. Address is a pointer, same as an unsafe address, but since this is not a variable, it doesn't know if this is going to be living, like it doesn't know if this is going to be something that we should actually access by pointer, which is why it's unsafe address. Like, we don't know where this pointer is. It could be on the stack, but since we're just copying from it, it should be safe. So same result, but this will be probably a bit faster than this. Right. I mean, we could have also done this in a loop, because this like read line, split, white space, these are already loops, so we could have written out these loops instead, so we wouldn't have to copy the memory, but then we would have to write this part ourselves. Right, so now we have all our boards and our numbers. We can close our input. So now let's play bingo. I'm actually gonna save this. Let's see. I'm gonna save this as input example, same as we did before. So now I can do this, and this should still work. And this is the example scenario that we're given here, so that we can verify that we get the same sum as the as the example here. So now we need to actually play bingo. So for each number, we need to loop through each of our boards. We need to mark it on our board, and we need to verify if that triggered a win condition. So we need to check horizontally or vertically and horizontally and make sure that placing this didn't complete the board. If it did, then we need to calculate the score. We can do a scoreboard as an array of five bulls, two-dimensional array of 5 bulls. I managed to switch to a workspace off screen. Why do so many people ask if I want to be famous on Twitch? I mean, obviously not. I'm streaming NIM content. Right. So we're just gonna do this in the sort of the stupid way. So we're gonna say scores is a sequence of scoreboards, and then actually we're gonna do is a new sequence of scoreboard that has the same length as our boards. This means that we can now index them right away. We don't have to populate them with empty scoreboards in the first iteration. So then we can go for number and numbers, and we can do for board and boards. We're actually going to grab the index of that so we can apply our score to the correct scoreboard. And then for line and board, for actually this would be y, for y, x. So for x, column and line. So now we have an x and a y value, and we have our board number. So if column is equal to number, then our scoreboard at this board position, at this y, at this x, is going to be equal to true. And here we need to do our checking. But let's first now just echo out. Let's echo out just our XY position here. So run this still on the test input. So, actually just echo out the I there as well. And just for clarity, just put a white space or put a new line in there as well. So for the first number on board 0, it finds one at position 4, 2. So 0, 1, so 4. Ooh. Right, so it should be 2, 4, not 4, 2. Line. Oh, right, yeah. We print them in X, Y, so that makes sense. So X position 4, Y position 2. So 4, 2, that's correct. And then at 2, 2, 2, that's correct. And then at 4, 4, 4, that's also correct. So that looks good. Now let's just remove these echoes. Now we need to do our check board. Actually, let's just write that as a procedure. Check board. I, X, Y, I guess. All integers. Returns true or false. So our board check should be, so for 0 dot dot 4 for x in 0 dot dot 4 and for y in 0 dot dot 4, we want to do scores, was it? Oh, this needs to be down there. So scores I and this is done. So scores I if the score of the ith board at the input y, oh, we shouldn't call this right, at input y and the iterated x, if that is true, if that is not true, we said done is false, and we can break this loop. We do the same thing here, and we say if done, return true. If it's not done, then it's false, so we don't have to reset it down here. Oh wait, we do. So done is true before this loop, and then loop down here if not scores in the given x, so input x and y. If that is not true, then we're not done and we can break. And actually our done could just be called result, and we can set result to false. And return. No, just break there. If I don't like all this checking logic. Let's create a block here called done. Break done. And here we then return. But that's not what we want to do. Here we want to break out. I'm trying to do something clever with blocks and returns here, just to show off how to do sort of blocks and breaking in loops and stuff. Because if we go through and result is still true down here, we just want to return. I can't think of a clever way of doing that. If result, return. Done. Yeah, so result is true. Result is false. And then down here it returns, like if it's false or if it's true, it returns down here. So that should now check if our board So we assume the board as like we have a line or we have a column. So we say result is true. This is a good board. And then we loop through to see if anything contradicts that assertion. So we start at the X and we loop through all our positions, or we loop through the line, and we see if the score of this board at the input Y, so at the position that we're at, loop through all the X's. If this is not a true value, then we return false. What we could actually do, because the score is all the sum of all unmarked numbers. What we could do, now that I think about it, is actually set, like, not have a separate scoreboard, but check if the board, like, if the board is 0. That would actually be pretty nice. So let's do that. You don't need this. And actually hold off on this for a little while. Oops. We'll hold off on that. And then we'll loop through all our numbers. If column is equal to number, because we don't have any zeros here, right? We do have a 0. But we have no negative numbers. But that doesn't work. Okay. We're going to do it this way. I was just thinking, like, if we, when we found a number, set it to 0, then the matter of calculating the score would just be summing up our whole array, because all the zeros would then just not count for anything. And then checking if a board was true was just summing up the X. Summing up the X, if it's 0, it's good. Summing up the Y, if it's 0, it's good. But since we have this, since we can have zeros, that won't work. And if we set -1 as our value, then those wouldn't work. Like we couldn't have those as like we couldn't do the whole like summing and stuff, because we would then sum with negative numbers. Oh well. So if we check the board and it's true, then we know that this board is good. Then we need to score the board. And what was it? The number. So we need to echo out the score of the board times by the number that we just chose. And we quit. So our program is done. So now we just had to write this scoreboard function. Not to be confused with our scoreboards. These are so poorly named. So score the board I, which returns an int. So this just takes for line in boards I, and I need an iterator there, and then for yes, so that would be line, and then C column in line if scores I line, actually just keep with the X and Y. Let's not make it harder than it already is. If this is true, so if this is not true, if it's not chosen, then the result adds in the board, or can just add in the column here. So grab a board, the board we're looking for, loop through all the lines with this as our iterator, so the number that we're on. Then in that line, go through all the numbers, so all the columns in the line, with this set an iterator, and then check the scores. If it's not set in the scores, then it's not already marked, and then we can sum up the result. So that should be 4512, which is the number that we got here. Great. So that seems to work. Could, of course, also for fun, we could write a procedure that outputs the board and sets the chosen numbers to bold. That could be cool. Then we could have an output similar to this. We'd see the winning board. But let's not do that right now. Let us take the input, our actual input. This is our score for our actual input, and it was correct. Nice. So part 2. Again, I'm trying to do these like not in a fancy way. I'm doing these just the easiest, the simplest sort of way possible. Just showing off more or less like idiomatic NIM code. Like this shows off like sequences and typical normal loops and all of that stuff. I'm not trying to do anything crazy here. If you want to see crazy NIM solutions, you should really have a look at the Advent of Code, our forum here. Especially like there was one, this guy has some pretty crazy solutions. Especially the one, where was that one? You can just go to his repo. For day 2, I think it was. Day 2 alt. Yeah, this thing. This is so good. So this one was the one with forward, up, and down, and calculating the numbers. He just creates procedures for forward, up, and down, and then he just includes his input. So if we look at the, oh, he doesn't have his inputs in his repo. If we look at the day 2 input, you can see this is actually valid NIM code, like forward space 4. That is actually just calling forward with the number 4. So he basically implemented, like he includes this as NIM code into his program. And then it just says, well, okay, I'm just calling these procedures and echoing out this sum. So pretty much this entire program is now being done. So like it just is a bunch of calls to functions to do this kind of stuff. So for comparison, my solution for day 2 is this thing. where I actually read through the lines and I split them up and I check the commands and then I do these things. And he's just, just let the compiler do it. Which I thought was really, really cool. Anyways. So yeah, if you want more crazy solutions to these, then definitely head over to the forums. People there are doing some fun stuff. So let's copy part 1 over to part 2. Nope. This is just the way I like to do it. I like to have a separate part 1 and part 2 file, and then just edit them. Because some of these you sort of end up doing one thing for part 1, and then you have to rewrite the whole thing for part 2. And I basically just wanna capture the moment of part 1. I want to capture like how I solved it and what I had to change to part 2, because I think that's interesting. Right. On the other hand, it might be wise to try a different strategy. Let a giant squid win. Like, he has hold of our submarine. We don't want to anger the giant squid. You aren't sure how many bingo boards a giant squid could play at once. I mean, he does have 8 arms, I guess. So, rather than waste time counting its arms... I mean, doesn't all squid have 8 arms? Isn't that a thing? Or am I just mixing them up with spiders and crabs and stuff? Yeah, so instead of wasting time counting arms, the safe thing to do is to figure out which board will win last and choose that one, because we don't want to win. That way, no matter which board it picks, it will win for sure. In the above example, the second board is the last to win, which happens after 13 is eventually called and its middle column is completely marked. If you were to keep playing until this point, the second board would have a sum of unmarked numbers, 248 for a final score of this. Right, so figure out the score of the final board that will win. So, I mean, basically, what we could do is just, so now we keep scores just for all the boards. What we could do is have a separate, like, completed boards, which could be a set of integers. Ooh, it can't be a set. So sets in NIM are bit sets. So basically, if I say a set of uint 8, then that's gonna just take 256 or 250, yeah, 256 bits, and then just set those bits for me. So if I said if I say a set of integers, there are so many integers that this would be a whole bunch of memory, and we don't need that much memory. If we look at our input, it's only 601 lines long, which means that we need 600 discrete numbers. So a uint 16 is plenty. So here, I just want to see if checkboard completed boards dot include the number of this board, and if completed boards dot card, so the cardinality of the set or the size of the set, which is the number of things that are set in the set, is equal to boards.length. So if we just completed the last board, so if all the boards now include one of the boards, then we do this. But we also want to do, like, we want to ignore boards that are already done. So if I is in the completed boards set, then we just continue this boards loop. So we grab a number, we go through the boards. If the board is not in the completed boards, then we carry on and keep calculating with it. And when we finish a board, if that board was the last board, then we print out the score. So, oops. Don't we have sets? Oh, right. This is a bit annoying with sets there. So since this is a set of UN16, we need to cast these to UN16. It's a bit annoying. It would be nice if we could do something like create a set that is the size of a variable, for example. Like I just want a set that can keep the amount of boards, but I don't know that on compile time, so I just default to UN16 instead. Right, so if we now do this on the example input and run this, then we can see it's 1924, which is our score, which is the correct score for the example input. So if we now change to the real input, we should now have a new number, which should be the correct one. Hooray! So another gold star for us, and the keys are once within our reach. So yeah, it doesn't say though if we get away from the squid until tomorrow, I guess, but I assume that we do. Yeah, that was day 4. So I think this one was easier. Like it's still, it's a bit of work. Like we need to do more work. I think this solution is longer than let's see, part 2. Oops. I think it's longer than our part 2 solution from yesterday. Yeah, by far. It's over twice as long. But I think this one was more complicated, if that makes sense. This is more sort of tricky, while this is just more work. Like none of this was hard. None of this really posed a challenge. We got it on the first try. It's just more work because we need to parse it into a structure and then do stuff with that structure. Of course, if the input set was way longer, then we would possibly need to find a faster way of doing it. And that is definitely something that's probably, like, if the earlier years are any indication, the further we go down, the sort of obvious solution won't work. Like just doing it the straightforward way just simply won't work because it's going to be way too slow. So hopefully we will still be able to find good solutions for those. But so far, I've just been focusing on trying to write sort of nice-ish NIM code. Sort of show off how the language works more than anything else. Like building types and converters and nice stringification methods and stuff like that, or procedures, I should say. Yeah, slowly introducing new ways of parsing. We probably last year I was using NPEG for a couple of these. It's a great library. It parses. It's a parsing library in NIM that uses a PEG-ish syntax. And the cool thing, like, it can do, like, this is output from the program, which is so cool. It's a macro, so you just write it as a domain-specific language into the file, then you match it to some string or a file or whatever. But the cool thing is that with a compile time flag, it will output stuff like this. Like it will actually write these out in your terminal, and you can generate a dot file. So a dot is a graph format, graph description language. So it can output code like this on compile time to a separate file that you can then run through a .graph generator program and get out a visual graph of the parsing grammar. And it will do that on compile time fully within a macro in NIM, which I find super cool. It's so nice having, like, writing a parser and then being able to, like, get the state machine as a graphical tree thing. So you can go like, okay, I'm at this stage, read through the file, like I can manually go through the parser steps and see where it messes up. And actually I've used this, like the output from PEG, I've looked at that and got like, wait, this doesn't make sense. It shouldn't be able to go from there to there, or it should have a link from there to there. And then updated my grammar book because of that. So that's a really cool tool, which we'll probably be using quite soon. I think the first one I used it for last time was number 7. Yeah, here's the terminal output, which again is just super cool that it outputs these on compile time in your terminal, or it can generate stuff like this. So yeah, that I think is going to be it for today. I'm obviously gonna add these to my repository, so you can check them out as code if you want to. Let's just add the input as well. And there we go. So if you want to, you can check these out on GitHub, on my GitHub, which is PMunch AoC. Yeah, PMunch AoC 2021. Here you have all my solutions, along with a link. Oh, I forgot to upload day 3 apparently. Along with a link to the playlist of these recordings. So if you want to see more of this, you can go to GitHub, go to this link, and find all of the recordings. But that's going to be it for today. Hope you enjoyed the stream, and hope you're enjoying Advent and the advent of code. Goodbye.